Good morning students, welcome to our maths class. In the last class, we have seen the rational numbers on closure property and commutative property. We shall recall that. What are the properties we have seen in the last class? Yes, closure property and commutative property. Okay. Then closure property is not true in which property the closure property is not true? Yes, the closure property is not true in division. Okay. Then next, commutative property is not true in which operation the commutative property is not true? Yes, subtraction and subtraction and say division. Yes, subtraction and division. Okay. Now closure property is true in three operations. What are the operations? Addition, subtraction and multiplication. Okay. Then commutative property is true in addition and multiplication. Commutative property is true in addition and multiplication. Okay. Now we shall move to our today's class. Today's class, we are going to see the associative property. For integers first, after that we will see the rational numbers. Okay. For integers, addition. For any three integers a, b, c, a plus b plus c is equal to a plus b plus c. Okay. Example. If you take a is equal to 2, b is equal to 3 and c is equal to minus 4. You substitute in this 2 plus 3 plus minus 4. 2 plus 3 plus minus 4. Now first you solve the bracket and remove it. 3 minus 4, yes, minus 1. 2 minus 1. Then here 2 plus 3, 5. 5 minus 4. Here 2 minus 1, the answer is 1. 5 minus 4, the answer is 1. So associative is true for addition. Okay. Then we shall see in subtraction. A minus b minus c is not equal to a minus b minus c. We shall prove that. Okay. And same, 2 is a is equal to 2, b is equal to 3 and c is equal to minus 4. Here a is equal to 2, then minus 3. B is equal to 3 minus C is equal to minus 4 is equal to 2 minus 3 minus minus 4. Now solve the bracket and remove it. 2 minus 3 is equal to minus 1. Plus minus becomes plus. So 4. Then 2 minus, you solve the numbers in the bracket. That is 3 plus 4, that is 7. So 2 minus 7. Now 4 minus 1 means 3. 2 minus 7 means minus 5. So these two are not equal. So associative is not true in subtraction. Associative is not true in subtraction. Now multiplication. A into b into c is equal to a into b into c. Now same, a is equal to 2, b is equal to 3 and c is equal to minus 4. So 2 into 3 into minus 4. Here 2 into 3 into minus 4. First you remove the bracket. 2 3s are 6 minus 4. 2. Then 3 4s are 12 minus 12. Now 6 4s are minus 24. Here 2 12s are 24. That's also minus 24. So both the sides are equal. So associative is true in multiplication. Then we shall see the division. A divided by B divided by C is not equal to A divided by B divided by C. Now we shall say the same. A is equal to 2 and B is equal to 3 and C is equal to minus 4. Same numbers you are substituting here. Okay. Then 2 divided by 3 divided by minus 4. Then 2 divided by 3 divided by minus 4. Now we shall remove the bracket first. 2 divided by 3 divided by minus 4. Then 2 divided by 3 divided by minus 4. In rational numbers we know that the denominator is always positive. So you have to bring the negative sign to the numerator. So 2 by 3 into minus 1 by 4. If you multiply, then you have to write this in reciprocal, isn't it? So if multiplication symbol and minus 1 by 4. 2 into, you have to change this to reciprocal. So minus 4 by 3. Now you cancel 2 and otherwise you multiply simply. 2 into minus 1, minus 2. Then 3 into 4, 12. Here 4 2s are minus 8. Then the denominator is 3. Now see, 2 by 12 minus 2 by 12 is not equal to minus 8 by 3. So associative is not true in division. Okay. Now we shall move to associative property for rational numbers. Okay. Till now we have seen the associative properties for integers. Yes. Now we shall see the associative property for rational numbers. Addition and multiplication are associative for rational numbers a, b, c. Here we are going to prove these two sums. Okay. In addition it is true and also in multiplication it is true. We have seen in the integers. Okay. Same for the rational numbers. We will take a is equal to minus 1 by 2, b is equal to 3 by 5 and c is equal to minus 7 by 10. Then first one is a plus b plus c is equal to a plus b plus c. Okay. Now we shall substitute a as minus 1 by 2, b as 3 by 5 plus c as minus 7 by 10. The bracket for a plus b. Then minus 1 by 2 plus 3 by 5 plus minus 7 by 10. The bracket for 3 by 5 and minus 7 by 10. Okay. Now this is the right hand side for us. This is the left hand side for us. First one by one we shall prove. First we will take this and prove the answer as both the answers are same. Okay. First we will take that left hand side. LHS. Okay. What is LHS? Minus 1 by 2 plus 3 by 5 plus minus 7 by 10. Here we have to see LCM for this to remove the bracket. Both the denominators are different here. So 5 2s are 10. Here 10 is the LCM. So you have to multiply both by 5. If you multiply 2 by 5, it will come 10. If you multiply 5 into 2, 10. So you have to multiply the numerator also. So multiply both the denominator and numerator by 5. Here both the denominator and numerator by 2. So plus minus 7 by 10. It will come as 5 minus 5. 3 2s are 6 plus 6 divided by both the denominators are same, no? So 10. I have taken one time plus minus 7 by 10. Now you subtract these two. Then it is come, the bigger number sign is plus. So 1 by 10 plus 7 by minus 7 by 10. Now both the denominators are same here. So no need to find the LCM. So 1 minus 7 by 10 is equal to minus 6 by 10. You can cancel 6 and 10 minus 3 by 5. Okay. This is equal to minus 3 by 5. We have taken the LHS as first equation. Okay. Then we shall prove the RHS. Now we will solve the RHS. Minus 1 by 2 plus 3 by 5 plus minus 7 by 10. So first you have to remove the bracket. So see the LCM for 5 and 10. That is 10. So multiply both numerator and denominator by 2. Here already it is 10. So 1 into 1 into 1. Then you take 1 times the numerator denominator as 10. So 3 2s are 6 minus 7. Then minus 1 by 2 as it is. Now we have to see the LCM for 2 and 10. Here already 10. Then you have to multiply both by 5. Then minus 5 minus 1 divided by 10. That is minus 6 by 10. You cancel and write 3 times minus 3 by 5. Then this is the second equation, minus 3 by 5. See the first equation, that also minus 3 by 5. So 1 is equal to 2. So a plus b plus c is equal to a plus b plus c is true for rational numbers. Therefore, the associative property is true for addition. And second sum, a into b into c is equal to a into b into c. Now, already same, a is equal to minus 1 by 2, b is equal to 3 by 5, c is equal to minus 7 by 10. Now, you have to take same that LHS first, then you will solve this RHS. Okay. A into b into c. First, minus 1 by 2 into 3 by 5 into 7 by 5. Then you have to multiply both the numerators, minus 1 into 3, minus 3. 5 2s are 10 into 7 by 10. Now you multiply minus 3 and 7. That is minus 21 by 10 into 10, 100. This is the first equation. Okay, take this as first equation. We have solved the LHS. Now we shall solve the RHS. That is A into B into C. Now minus 1 by 2 into 3 by 5 into 7 by 10. Now we shall remove the bracket. Then multiply the numerators. 7 3s are 21. 5 10s are 50. Then already minus 1 by 2 is the A. So you multiply with the A. That is minus 1 into 21 minus 21. 2 into 50, 100. So the second equation also minus 21 by 100. So 1 and 2 are equal. 1 is equal to 2. A into B into C is equal to A into B into C is true for rational numbers. Therefore, the associative property is true for multiplication. Now, we will see the exercise 1.2 in Jesse. Express each rational number into a decimal. Okay. Now, 31 by 5. First one, A. How to make this as a rational number? We can multiply this 5 by some number, means it will come 0. Isn't it? What number we have to multiply? By 2. If you multiply 5 into 2, then the answer is 10. So here, if you multiply the denominator, you have to multiply the numerator also. 31 into 2 is equal to 62. So 62 by 10 is equal to 6.2. So the answer is 6.2. Okay, we have changed the rational number to decimal number. Okay. The next one, 66 by 4. You have to multiply this 4 by some number, then it must come 0. That is a 10 or 100. Then it is easy to change to decimal number, isn't it? So, if you multiply 25 into 4, 100. When you are multiplying the denominator by 25, you have to multiply the numerator also by 25. So 66 into 25 is 1650. 4 into 25 is 100. Now you can cancel on 0. Then 165 by 10 is equal to, you have to put point after one digit. So 16.5. Okay, 16.5 is the answer. So now we have changed the 66 by 4 is in rational number. we change that to decimal number. The next one, 102 by 204. Here 102 twos are? Yes, 204. So you are cancelling 1 times, it is 2 times. Then 1 by 2. If you multiply 2 by 5, it is 10, isn't it? That is, you have to multiply the numerator also by 5. So 5 by 10. 5 by 10 means 0.5. Answer is 0.5. F sum 8 by 64. Here solution 8 by 64. 8 table we can cancel this 1 times and 8 times is equal to 1 by 8. Here we don't know to multiply that 4 or 5, we don't know. So we are simply dividing. So 1, 8. 1 is not enough. So you are keeping point and adding 1, 0. So 8 ones are 8. Then subtract 2. Then add 1, 0. We have put 1 point means we can add 1, 0. Okay. 1, 0. Then 8 twos are 16. Again you subtract 4. Then 0, 40. Then 8 fives are 40. 0. 40 minus 40, 0. Then now the answer is 0.125. So answer is 0.125. Okay, we have changed that 8 by 64. Rational number to decimal number. Then we shall see express into a repeated decimal. We are going to express the number to repeated decimal. Repeated decimal means 272727. It is coming now again and again. The same number comes means we call that as repeated decimal. Okay. Now we will divide the 47 by 11. So 47. 4 times 11 fours are 44. Then you subtract. That is 3. Then keep point. It is not enough. 3 is not enough. So you are keeping point and adding 1, 0. Okay. Then 30. 11 twos are 22. Again you are subtracting. You are borrowing and 10 minus 2, 8. Okay. Then 8 is not enough. 8 is smaller than 11. So you are adding 1, 0. 80. Then 11 sevens are 77. So again you are subtracting, borrowing and 10. 10 minus 7, 3. And add 1, 0. 30. 3 is not enough. 3 is less than 11. So add 1, 0. 30. Okay. 30 means 11 twos are 22. Again it comes 22. Twos are. And again you are subtracting. It will come as 8. Then add 1, 0. Again 7 times. And it is repeatedly coming as 27, 27, 27. Again it is coming 3. 3. We are adding in 0. Again it will come as 8 remainder. So we can write the repeated decimal as 4.27 bar. You can write like this. 4.27 bar. Why you are writing bar? The 27 is repeatedly coming. So we are writing bar for the 27. So now the repeated decimal for 47 by 11 is 4.27 bar. Thank you. Have a nice day.